Hey guys, this is Mrs. Gassler. We're going to talk about atomic structure. We're going to sum up all of our different models and then think about what we currently know about atomic structure. And then we'll kind of lead into some other stuff that we're going to talk about. So we're going to draw a model of the atom. Now remember that Dalton guy, he came first and he had just a plain old atom, nothing inside it, solid ball. In fact, he thought about them as being kind of like marbles that would stick together. Each marble was different for a different element. And then that guy, so that was Dalton. And then remember that guy, Thomson, came along and he said, you know what, there's actually a bunch of pluses and minuses in there. Overall, it's neutral, but it is all jumbled up inside and not at all organized. And then along came this other guy, Rutherford, and he said, you know what, Thomson, you're a little bit wrong. There's some stuff in the middle. Whoops, the positives are in the middle and the negatives are around the outside, like that. So then that's kind of the model that we use, the Rutherford model. There's more to it than that. It turns out that the electrons are a little bit more organized, and we'll see those later. So we're going to draw a generic atom here, and I'm going to start by drawing kind of an outline. This outline doesn't exist. There is no outside of an atom. There's just the furthest away electron, and then we've got this tight thing in the middle. And so you might remember that this thing is called the nucleus. It's the center of the atom, and it only has some things in it. In fact, what it has is pluses and zeros. The pluses are what we use for a proton, and the zeros are what we use for a neutron, which we'll write down a little bit about what those are. Now, around the outside is what we're calling the electron cloud. There is some arrangement to the electron cloud. We'll get to that in another video. But the electrons are around in that electron cloud. So these little minuses, those are our electrons. So when you're thinking about the structure of the atom, that's pretty much it. So let's kind of review. We've got our protons. They are positive, and they are in the nucleus. And we have our neutrons, and they are neutral, and they are in the nucleus. In fact, that's how I remember it. A lot of people think that neutrons are negative just because it starts with an N, but they're neutral. Neutrons are neutral. Neutrons are neutral. Neutrons are neutral in the nucleus, and then electrons are negative. And they are not in the nucleus. And there you have it. That's the basic structure of an atom. In this video, we're just going to review some of those definitions that we've been learning about to identify some information about an atom. And so we're going to make a short list. There's not very much to it, but we're going to kind of sum those up so that we can make sure we can keep them straight. So here's our definition. So our first one is going to be atomic number, and the atomic number is the number of protons in an atom. That's it. That's just what it's defined as. There's nothing to understand. The atomic number is just defined as the number of protons. So that's important because we use that to identify an atom. Using the atomic number. They're in order on the periodic table of atomic number, that whole number 1, 2, 3, 4 through 118. That tells you which atom you're looking at. So that's the number of protons. So what happens if you change protons? When you change protons, you will get a new element. When you look at the mass number, that one's a slightly different thing. That is the number of, and remember, protons, neutrons, and electrons are called subatomic particles. So it's the number of subatomic particles that are in the nucleus. So that really doesn't mean a whole lot, except that it does not include electrons. So another way to write this is that we're including protons and neutrons. Okay, protons and neutrons make up the mass number. Now, this number is not in the periodic table. That's really important to note. A lot of people try to look up the mass number in the periodic table, but it's not there. The mass number is not in the periodic table. It's not in the periodic table. We'll write down what is in the periodic table in just a second, but if you want to figure it out, you'll have to look at protons and neutrons to figure it out, or you'll have it and you'll need protons and neutrons. But what's in the periodic table is an average of those. If you change, so I'm going to write neutrons here. If you change the protons, you're going to get a new element, but if you change the neutrons, you get a different isotope. And an isotope is just a fancy word that means an atom that has the same number of protons but a different number of neutrons. So that's an isotope. And that's why we can't have it in the periodic table, because each element has a couple of different isotopes that it might need to list. And if we listed the mass numbers, then we'd have a lot more information to put in the periodic table. So what is in the periodic table is the average atomic mass. It's not the mass number, and sometimes it's called the average atomic weight. Sometimes it's just atomic weight or atomic mass, but it's an average. And it is an average of all the isotopes of one element. And we'll talk about how to calculate the average atomic mass in another video. But basically you have different elements, have different isotopes, and if you average up all the different ones that you could have, it's a weighted average. We should note that down, it's a weighted average. Then you'll have the average atomic mass that's in the periodic table. So these are just some definitions to review: atomic number, mass number, and average atomic mass. We're going to talk in this video about atomic notation. That's different ways that you can write out the element, the particular element and isotope that you're talking about when you're talking about atoms. So I'm going to give these some random names here. This first one I'm going to call shorthand notation. Shorthand notation includes a letter. I'm going to write the format over here and then I'll show you some examples. So the format is going to look like this. It's going to have a letter or letters, and then it will have two numbers, a high number and a low number. This high number represents the mass number and the low number is the atomic number. Now sometimes the atomic number is optional because you can just look that up in the periodic table from the symbol that you would write down. But sometimes, especially later on in chemistry class, you kind of really need that atomic number to be able to work with. So the letter I just said was the element symbol. And so let's look at some examples of what this one looks like. So let's say that we have uranium, 238 and 92. So the 238 tells us the mass number. There's 238 things in the in the nucleus, and there's 92 protons, so you can figure out how many electrons there are, not electrons, how many neutrons there are. We could also write helium. Helium has an atomic number of 2, and let's say it has a mass number of 4. Gold is atomic number 79, and maybe we're looking at the particular isotope 197. Maybe we want to look at a different isotope of gold, so we look at 196. So we can tell which isotope that we're looking at. Now sometimes another way that we could write this down where we're just writing down what it is, I call this name notation because it includes the name. Okay, especially when you're writing out the words or in sentences when you're talking about a particular isotope that you have, you would see it this way. And so the format that you would see is the element name. I write that like it's one word, dash, and a number, and the number is always the mass number. Biggest mistake people make with this one is thinking that number is the atomic number, and it's not. So I'm going to use the same ones from up here as my examples down here. So that U stands for uranium, so that would be uranium 238. The one next to it, helium with the 4 on it, this would be helium 4. Now we can tell these two isotopes of gold from each other by writing this down, gold 197 and gold 196. That's the name of that particular isotope, so that's why I called it name notation. Okay, so the last notation, which I'm going to call the I'm too lazy to write the name notation. And you'll see why here in a second. So this is what this one looks like. This one is sort of a combination of these two. Instead of the element name, we write the symbol and the number. So this here is the symbol for the element, and that there is the mass number. So it looks just like this one, but instead of the whole name, we're going to just write out the letter. So that would be U-238. This would be helium-4. This would be gold, which is AU-197, and gold AU-196. So, whoops, I forgot to label that. These are our examples here. So when you look at those, they're pretty much the same. We're just writing the letter out. So these are the three different ways you might see some isotopes telling you what atom you're dealing with. And all of them are going to give you enough information to get everything else you could possibly need to know. You need to know something about how many neutrons there are. And the mass number is the only number that includes neutrons. You need to know how many protons there are. From that you can get electrons and whatnot. So you have to have those two numbers. Okay, you have to know what it is and how many neutrons there are in order to be able to figure everything else out. So these are the different ways you might be able to read it, or you might be able to see it. In your homework, you probably have to fill out a chart where you might have to write these down. So if you are having trouble figuring out the numbers of protons, neutrons, and electrons, that's probably why I told you to watch this video. Protons, electrons, and neutrons. Sometimes we abbreviate that as PEN. Protons, electrons, neutrons, PEN practice. So you've got these worksheets where you have to find out the numbers of protons, neutrons, and electrons, and probably some other pieces of information. And so what we've got to look at is all those different things. We need to sum those up as best as we can. And then once you have those things summed up, hopefully it gets a little easier. All right, so protons, neutrons, and electrons. Okay, so what you need to know, there's three things that you need to know. You need to know what numbers should be the same, and then how do you get the rest of the numbers that you don't have. Okay, so the first thing I always look for is the atomic number. Sometimes it's given and sometimes it's not, and if I have it, then I know a couple of other things. I know that the atomic number is the number of protons. And I also know that the atomic number is the number of electrons. Now, I can't remember who talked about ions yet. Ions sometimes have different numbers of electrons, but a neutral atom, which I'll make a little note here, has the same number of protons as it does electrons. So those three numbers are equal. So if you know this one, you know those other two. If you know this one, you know those other two. If you know this one, you know those other two. So one of those gets you the other three. So once you have those filled out, or maybe you don't have any of those, so you can't do that one yet, then maybe you need this piece of information. The atomic number comes from the periodic table. All you have to do is either look up the element name or the element symbol. So if you have a name or a symbol, you can find it in the periodic table. If you have an atomic number, you can find the element name or the symbol by looking up the atomic number. If you know one of those, you know the other two. Which means if you didn't have the atomic number, but you had an element name, now you have a link to get up there. So the element name comes from the atomic number. You get one from the other. So then the last thing that we need is those gosh darn numbers of neutrons. And that comes from the mass number. So the mass number is not the number of protons, it's not the number of electrons, and it's not the number of neutrons, which makes it a little irritating. It is the number of protons plus, and I'm going to try and darken this in as much as I can here, it's plus the number of neutrons. That means if you know the mass number, but you don't know any of these up here, you're gonna have to do some subtraction. Actually, you wouldn't know the mass number and not one of these. You'd need one of, if you've got two of these, you'll have to do some math. So a little side note here, the number of neutrons would be the mass number minus the atomic number, which again, if you know the protons or electrons, you know the atomic number. And the number of protons would be the mass number minus the number of neutrons. So it just depends on what you have as to what you can get. You just have to know the relationships between these to be able to get them. I do want to write down 2 notes. The mass number is either going to be given or needed. Okay, so you'll either have this and you'll need one of these, or you'll have these and need this. Or maybe you have neutrons and the atomic number, which means you do have the number of protons. So you just have to figure out what they're equal to. The last thing that we have to say is that the mass number is not in the periodic table. You can use the periodic table here to get from the mass or the atomic number to the element name or the symbol, but you cannot use the periodic table to get the mass number. It's not in there. Remember, that's the average atomic mass, which is not the same as the mass number, so don't use that one. So make yourself a copy of this. Take your handy worksheet and then just start going through. What do you know? What can you get? Find it on here. Oh, I have the atomic number. That means I can have the number of protons, electrons, the element name, and the element symbol. Oh, I have the number of neutrons and the atomic number. Okay, so then I can get to the number of protons to find my mass number. You can do this. You just have to know what you have and what you need. So if you need some more practice or you want to go through some of them with me, make sure you ask. Thanks.